geometric series. We're talking about 5.04 geometric series. We talked about 5.03 on Tuesday. Now we're talking about 5.04. So let's talk about what a geometric series is. Now we talked about what a geometric sequence was. Remember, we've got like 2, 6, 18, ... Right? If it was an arithmetic series, then we would be adding the same number every time or subtracting the same number every time. But this is obviously not, because that would be adding 4 and then adding 12. So we don't have an arithmetic sequence, but we do have geometric, because if you take it times 3, 2 times 3 is 6, 6 times 3 is 18. So that is our sequence on there. So our R equals 3. That's our common ratio. Common ratio. And we call it a ratio because if we put this as a fraction, 2 to the 6th is the same ratio as 6 over 18, which would be the same ratio as 18 over 54, which would be the next number in the sequence. All of them follow the same ratio. 2 over 6, 6 over 8, those are all equal to each other. So R is our common ratio. So let's talk about, as a series, just like we did in the arithmetic series, we have a formula to where we can find the sum, S of n. The sum, which means we add up the terms. If we just add up the first 3 terms, S of 3, 2 plus 6 is 8, 8 plus 18 is 26. So S of 3 would be 26, because that's the total of the first 3 terms added together. All right, but that's easy because we have those terms right there. Let's say we wanted to know S of 12, right? S of 12. Well, we'd have to do a lot and add them all together. And that. So let's see what our formula is. This is the recursive formula. Remember, we had 2 different kinds. This is recursive. So this is great for your notes. So it uses A sub 1 minus A sub n times our common ratio divided by 1 minus our ratio. Okay, that is the recursive formula for sums. So what do we need to know in that? Well, we need to know what the first term is, right? A1, which is 2 for R's. We need to know what the R is, the common ratio. Our R is 3. And we need to know what the nth term is. So for S of 12, we would have to know what A sub 12 is in this case. If we would need to know A sub 12, the 12th term. Well, we don't know the 12th term. We haven't calculated that. We haven't done that. So let's see. We had the other day, let me go back and pull out our note sheet from the other day. We had our formulas for finding, and I have buried them in my, oh, they're on this other page. Our geometric sequence notes. We did have a formula, a recursive and explicit, to find the 12th term. So we can do that. So let's go ahead and find the 12th term. So A sub 12 equals A sub 1 times R raised to the power of n minus 1. Okay, so we can find the 12th term. A sub 12 equals A sub 1 is 2. That's our first term. 2 times R to the, this is 12. That's what n is. So R to the 11th. Oh, I can substitute R too. Instead of R is 3. So the 12th term is 2 times 3 to the 11th power. So let's pull out our trusty calculator. We can trust it as far as we can throw it, right? Oh, and it's our computer. We don't want to throw it. 3 raised to the 11th power is this much, and we need to multiply that by 2. So the 12th term is 354,294. If we continue this series out to 12 terms, we will get 354,294. So now that we have a sub 12, a sub n in this case, it's 354, or a sub 12 in this case, 294. So let's use our formula to see how much it would be to add up the first 12 terms. We know it's going to be bigger than that, right? Because we're adding these numbers to it and all the other numbers that come before it. S sub 12 equals a sub 1, that's 2, be a fraction here, minus a, which again, a sub n, which is 354,294 times our common ratio, times 3. All of that divided by 1 minus r, 1 minus 3, or negative 2. 1 minus 3 is negative 2. So let's get our calculator back and do this math right here. So we'll start with the multiplication because order of operations, right? 354, 294 times 3. So I'm going to write this down. 1062882 divided by negative 2. All right, so now we'll move our calculator over. So there's what that equals. So I'll clear this out. Now 2 minus that. 2 minus 1062882 equals negative 1,062,880, and divide that by negative 2. Negative 2. So if we add all the first 12 terms together, it equals 5,031,440. Woo. Well, gosh, we had to use 2 different formulas and jump through all of that hoops just to get to that answer. Surely there's another way. Well, of course there's another way because we saw 2 ways in the arithmetic series. Let's look at the second way in the geometric series. So let's look at the explicit formula, where we can just jump straight to the answer without having to go back and figure out what a sub 12 is. The explicit formula for a geometric series, S sub n equals A1 minus A1 again times R to the n divided by 1 minus R. Okay. So for your notes, you would want to have the explicit and the recursive formulas in your notes. So you can use them on the test and the assignments, and you probably want to have an example of how that works. So let's use the explicit formula to find the sum of the first 12 terms. We should come up with the same answer unless something's wrong, right? So a sub 1, 2, again, 2 minus 2 times R is 3 to the 12th power, 3 to the 12th power, because it just says n. It doesn't say n minus 1 this time. And since our n is 12, R to the 12th, and all of it divided by 1 minus 3, or negative 2. All right, so we need to figure out 2 minus negative 2. We need to figure out what 3 to the 12th times 2 is. All right, so 3 raised to the power of 12 is that number right there, times 2. Well, looky there. 1062882. Now we've got the same equation that we had right there. So we're going to get the exact same answer. Same answer because we have the same numbers. 2 minus 1,062,000, 2 minus 1,062,000 divided by negative 2. So either way, we get to the same answer of 531,440, except this was a lot less work. We didn't have to go back and find A12 first to substitute into the formula. We were able to just jump straight to the answer with just one formula. So that's how geometric series work. That is lesson 5.04. This formula we used here was from 5.03, which we looked at on Tuesday. So altogether, we got our 4 formulas that we've learned this week. This helps find a number in the sequence. These find the total of adding numbers together in a sequence up to the nth term. This will help you find the nth term. This will help you find the sum up to the nth term. So there's what you would need in your notes. All right, any questions on that? It's just a follow-up from Tuesday to get the 504 lesson. So that should give you everything you need. You have your assignment. Several people have already done the assignment informative. People are doing well on it. They're doing great. So if anyone has any problems, I'm happy to help with it. But otherwise, let's see, this is a BABB week, but here's the good news for you. I'm not going to be here tomorrow, so you don't have to get up early tomorrow to see my lovely face, because I'll have my camera working by tomorrow. You don't have to get up and see me tomorrow because I'm not going to be here, so we will not have class tomorrow.